This video is the fourth video in the Chemical Solutions set of videos for Leaving Certificate Chemistry. In this video, we're still looking at section 2 of Chemical Solutions, which is all about the units of concentration. In terms of the learning intentions covered in this video, we're looking at the final two learning intentions on this slide. We're going to be able to define molarity by the end of the video, and we'll be able to express the concentration of a solution in moles per litre, which is known as molarity. As I mentioned in a previous video, the concentration of a solution can be expressed in several ways. Firstly, as percentage concentration, secondly, as parts per million, and thirdly, as molarity. In the last video, we looked at parts per million, ppm, or milligrams per litre. In this video, we're going to focus on molarity, which is moles per litre, which can be given as a capital M. And in the first video on units of concentration, we focused on percentage concentration. So percentage V per V, percentage W per V, and percentage W per W. A 1 molar solution, or 1M, and capital M, which is really important, contains 1 mole of a solute dissolved in 1 litre of a solution. A 0.5 molar solution, or 0.5 capital M, contains 0.5 moles of solute dissolved in 1 litre of solution. Similarly, if you had a 2.5 molar solution, that would be 2.5 moles of the solute in 1 litre of solution. An important key term is molarity. All molarity is, and it can be defined as a capital M, the number of moles of solute per litre of solution. It's quite common to be asked to express the concentration of a solution in molarity. Over the next 3 slides, I'm going to go through 3 examples of different types of questions where you're asked to give the concentration of a solution in moles per litre. Example 2.10 says, what is the concentration in moles per litre of 1 gram of NaOH, which is sodium hydroxide, in 1 litre of solution? And thankfully here it gives us the relative molecular mass of sodium hydroxide, and that is 40 grams per mole. To start this question, I'm going to have to change it into the number of moles. Again, I use the formula number of moles is equal to grams divided by m(or). The grams here is 1. And the m(or) they've given to us, and they've told us to use the relative molecular mass as 40. So we 40 grams per mole. The number of moles then is calculated by 1 divided by 40, which tells us that the number of moles is equal to 0.025 moles. Now that 0.025 moles of sodium hydroxide is in 1 litre. We've been asked to express the concentration in moles per litre, and you can see here that we have expressed it in moles per litre. Therefore, we have a 0.025 molar solution, big capital M. Example 2.11 says, what is the concentration in moles per litre of 22 grams HCl, or hydrochloric acid or hydrogen chloride, in 200 centimetres cubed of solution? The relative molecular mass of HCl is 36.5 grams per mole. Here again, we're going to have to change the 22 grams of hydrochloric acid into moles. We do that using number of moles equals to grams divided by m(or). The grams they've given to us, and that is 22. And the m(or) they've also given to us, and the m(or) they've said to use is 36.5 grams per mole. Figuring out the number of moles becomes 22 divided by 36.5. Typing that into your calculator, you'll figure out that the number of moles is 0.6027, and the numbers continue. I'm going to leave that as 0.6 moles. Now we have 0.6 moles in 200 centimetres cubed. It's asked us to express the concentration, or what is the concentration in moles per litre. We have it in moles, but we don't have it in litres. We have what 200 centimetres cubed is. Now, to keep it constant, I always go back to what 1 centimetre cubed is and then to 1,000 centimetres cubed. So I'm going to divide both sides by 200 and multiply both sides by 1,000. When I do that, I'll have 0.6 divided by 200, which will give me 0.003. And I'm just going to show the examiner exactly what I'm doing by dividing by 200. And then I'm multiplying by 1,000. And I'll get 0.003 multiplied by 1,000, which will give me 3 moles. Therefore, we have 3 moles of HCl or hydrochloric acid or hydrogen chloride in 1,000 centimetres cubed. That means that it is a 3 molar solution, capital M. Just to note too, you could, if you wanted to, when we had 200 centimetres cubed here, to make it up to 1,000 centimetres cubed, you could have multiplied it by 5 and then multiplied 0.6 by 5.2. However, I always like to do the exact same method every time, so I like to go to what 1 centimetre cubed would be and then up to 1,000 centimetre cubed, but either is perfectly correct. Example 2.12 says, what is the concentration in moles per litre of 4 grams sodium hydroxide or NaOH in 750 centimetres cubed of solution? The relative molecular mass of sodium hydroxide is 40 grams per mole. Again, we've been given the mass, however we want it in moles, and we use our formula number of moles is equal to grams divided by m/or. Here, the grams is equal to 4, and they've told us that they want to use an m/or of 40. To calculate the number of moles, it is 4 divided by 40, and that will give us the number of moles as 0.1. Now we have 0.1 mole in 750 centimetres cubed. We want to figure out the moles per litre, so I need to go to 1,000 centimetres cubed. So to go to 1,000 centimetres cubed, I'm first of all going to go to 1 centimetre cubed, and then I'm going to go to 1,000 centimetres cubed. To get down to 1 centimetre cubed, I'm going to divide both sides by 750. And then I'll multiply both sides by 1,000. First of all, I have 0.1, and I'm going to take that 0.1 and divide it by 750. When I do that, I'll be left with 0.000133 ... Then I'm going to multiply that by 1,000, and I'll be left with 0.133 ... However, I'm going to round that up and I'll get 0.13 moles in 1,000 centimetres cubed. What this means now is we have a 0.13 molar solution, as molarity is in moles per litre, and I can represent that with a big capital M. Checking in on what we've completed in that video then in terms of learning intentions, we've got the entire section of the learning intentions for units of concentration completed. So you should be able to define molarity in particular after this video. Molarity is just the number of moles per litre. And then we should be able to express the concentration of a solution in moles per litre. Usually you'll be coming from grams per litre, or grams per 200 centimetre cubed, or grams per 750 centimetre cubed, as you've seen in the last few examples. But mostly you need to be able to transfer from grams into moles to begin with, which is using your formula number of moles is equal to grams divided by m/or, and then changing from whatever you are, be it 200 centimetres cubed or 300 centimetres cubed, and bring it up to 1,000 centimetres cubed. That then brings us to the end of this video.